And so go insert it more and more rapidly because I think that you're kind of getting the hang of it, hopefully. We're now going to look quickly at diverging lenses. Okay, and so I've got a diverging lens right in my little packet over here. And so here's a diverging lens. That's a pretty strong one. Here's a less strong one. Let's pull it over like that. And diverging lenses are very similar to convex mirrors. And again, so I didn't state this explicitly. You got to remember it from chapter 13. I'm not going to repeat it all the way through again, but images are always virtual and smaller. So I'm going to take and I'm going to make a little diverging lens here. Now what's going to make the diverging lens diverging is instead of cutting off this piece here, I'm going to do a little build out. I'm going to build out some material like this, and I'm going to have my lens material over here. So it's going to be thinner in the middle and thicker at the edges. Okay, and so now I've got my optical axis one more time. And if I have a ray of light cruising through the optical axis, it just goes all the way through. Now if I have a ray of light up here, it's going to cruise through like that. And now I'm going to define a normal again. And that's probably going to be the same, probably drawing it like I did in a previous one. So that's basically my same 15 degrees. So if I dredge up where I looked at before, that was, if I do my calculation, it's going to come out at 24 degrees. But now it's going to come out at 24 degrees this way. So now my ray of light is going to diverge that way. And if I have the same thing happening down here, it's going to come in like that. And then Snell's law takes into effect at there. This is where Snell's law really takes into effect. And it's going to come out. Let's see, that's 1, 2, 3, 4 boxes, 1, 2, 3, 4 boxes, somewhere like that. And so it's going to come out like that. And so my rays of light are going to diverge. Okay, and so then if we look at a ray tracing for this, we're going to go optical axis, and we'll put this out. Doesn't even really matter all that much. So this is my diverging lens, otherwise known as concave. And this is my optical axis. And we're going to go, let's say, here's my focus, and going over on the other side, here's my focus. So my focus is 4 centimeters. We'll put my object out here. And that guy is at 5, 6, 7, 8. Now, watch this. Before, I had, this was, I said this was focus 1, this was focus 2. Now, we're going to flip-flop them. We're going to turn the lens inside out. So this is focus 2 and this is focus 1. We flip-flopped the foci because before in the mirrors we had a focus that was in front of the mirror and behind the mirror. Now we've sort of got the same thing where the two foci have flip-flopped, and so now I diverge. So I go out along a line like this. And then if I head in towards this focus, that's heading towards that focus, this ray of light leaves parallel and I'm going to back it up because we know we're going to have a virtual image. And then this thing here, this one keeps going. That's good old straight through the center, good old straight through the center always works. So I flip-flopped my foci. So instead of going here, here, I now go here, here. Instead of going here, here, I now go that way and then parallel. And so I have my little dude right here. That's my image. And so I go 1 over I is equal to 1 over 4 centimeters minus 1 over 8 centimeters. And so I is going to be one divided by 4 minus 1 divided by 8. Oh, stop. Hang on. We gotta remember. Oh, I just turned it off. I gotta take the. Why did I get something wrong? If I do this, I get 8. But it's not 8. Oh, I remember what I did wrong. So in the mirrors, when we went from being concave to convex, the focal length went from being positive to negative. So we got to remember, we flip-flopped the foci, so the focal length is negative, so that's negative, so I get 1/4 1 over negative 4 minus 1 over negative 8, so 1 divided by negative 4 minus 1 divided by 8, then I flip-flop it,